There he is.
Morning.
How you doing, Wenjing?
I'm doing good.
Good. Cranking along. This is what we want to see. And here comes Sam.
Sam.
Hello, guys.
How you doing, Sam?
I'll keep him busy.
Yeah, the carry engine keeps firing. Yeah.
Yeah, yeah. Hopefully it won't sputter out.
How is the healthcare the thing it's your son-in-law. Is he still working on that?
Yeah, they're actually in they're part of Techstars Boston, so they just completed the first 3 weeks. And then I think uh the first week of December is when they do I guess they're when they complete. So it's they don't have to be on site the whole time. So they were there for 3 weeks and now they're back home, and then they'll go back again at the end to do the final thing. So they're getting a lot of attention from the medical community because the Techstars Boston is the medical tech uh,
Ah, that
incubator for Techstars.
that makes a lot of sense. Yeah, that would happen there. Good. Welcome, Kevin. Yes, a new face, and if we have a small group today, because you'll see one of our agenda items is that we all right, can you hear us okay?
No, I can.
Cool. So I tell you what, let me yeah, we're at 3 after, and I don't expect necessarily a large group. So I'm going to go ahead and get us started, and then Kevin can do an intro, and we'll tell you why Kevin's here, what's interesting about all the stuff that he's working on. All right, let me share my screen here. Yes, okay. And for our recording, welcome everyone to our October 1st, 2025 meeting of the Trust Spending Protocol Task Force. And as always, we share our agenda, our antitrust policy notice here, and then our special in the technical stack working group notice about our 45-day maximum limit on declaring any exceptions to a contribution. For Kevin's notice, this is standard for all Linux Foundation projects, and we have this in order to pull in one clause from the Open Web Foundation that does not let someone linger until the end of a spec to declare essential claims. If you're familiar with that, yeah. So anyway, and we can start out right away with new member introductions. Kevin, would you like to give a little background, and then Wenjing and Sam will each, you've spent enough time with me, and Kevin will tell you why, and Wenjing and Sam can you can learn about their backgrounds too. We are the three co-chairs of this task force, so it's just us today. Go ahead, Kevin.
Wonderful. Yeah, I like the intimate setting. So obviously with the gray hair, I've got a long life story. I'll shorten it. Electrical engineer, always been interested in technology, gradually shifted from hardware design to software. So mostly software now. Gosh, I've touched almost every language and structure framework there is, from databases to front end. And also I've got this weird aside life as a business owner and filmmaker, making documentaries and videos, learning how to manipulate people, basically learning the propaganda side. Since I retired in 21, I've been focused on collective decision making, and that's led me to sense making, which led me to information, and then this network, which then leads to digital identity and trust and data sovereignty and community. So I'm at that intersection between social tech and hard tech, I'll call it. And I've been digging into trust over IP, and of course, fell right immediately into the choke point, the trust spanning protocol. I'm with the Drummond on a couple of projects, and this idea of a standardized protocol seems critical, like it's in the critical path for what we want to do. But mainly, my ultimate life goal is to move decision making and power from a small number of people to a larger number of people, more democratic, getting more people involved in decisions. And what that's led me to is local. Let's start local. Let's start in cities and counties. And because I think we have more influence there. And also the decisions are more impactful there too, even though we've got these larger global concerns. So again, that's led me to how can we connect people using this internet, which is unprecedented in human history, the speed at which information can flow and connections can form. So, and then that's one of my other super skills is connecting and weaving. I'm in lots of different projects and groups. So again, a network effect is kind of like where I see a lot of power. So that's basically me. And I appreciate being able to just eavesdrop today.
You are more than welcome. My one regret is that another superstar in the Trust RP community just joined us, and she missed all that.
But it's recorded, hopefully. But yeah,
Yes.
thank you.
Welcome, Carly. And
Hello. Sorry, I'm late.
no, not a problem. You just missed a wonderful introduction from Kevin, but I did get the highlights in the
I'm
notes.
reading it. I read it. Looks great.
Oh, there you go. Excellent. Excellent.
Thank you.
So Kevin and I have been part of the larger group working together on something called NAEU Genesis, Network Adaptive Organism Genesis. It's described in part 10 of the first person white paper if you're interested. So since we have a small group today and not a large agenda, and because I think it'd be great for Kevin to get a sense of the other three of you, could everyone just do a short for Kevin, short bio for yourself, short intro for yourself. Let's start with, I'll just go down the list. Wenjing.
Self introduction.
Yeah.
Okay, good. Yeah, I don't know how to. So I have mostly my work as a software engineer since late 80s. My actually graduate work or early work is the some of the early protocols used in internet routing. And that's how I started in routing protocols, and then into sort of a numerical analysis of traffic on the internet and how to do traffic control. So that's my kind of thesis on um, research on how to do a algorithm in the local point that can help um, um, direct traffic so that in the globally, in the big picture, that it moves better. Actually, some of that could be used in real highway traffic or street traffic control as well. But anyhow, I work with many different companies. Eventually, I think moved to the Valley here in the Bay Area and work on a couple of startups in the 90s, and then later on worked with data centers with the Dell, back then is a research center here, and from there into cloud computing, and now identity, really as a kind of a very roundabout way of coming down to this. Um, so I've been working on this for what, with Trust of IP for 5 years now. And I guess, at least in this context, most of my work is trying to get the trust spanning protocol fully specified and properly implemented that can be used. I think the design idea of the trust spanning protocol would fit some of your ideas of, more local control or even personal control very well. Um, it doesn't try to solve this problem on its own. It takes this is, again, my own background. It takes the early internet's idea that large complex problems should be solved by different layers. And so that we want to provide a layer um, that is low enough so that you could make very fundamental decisions, uh, sort of ascending the foundation. You can think of it as a basic rules of the traffic, and then other smarter people can then build really impactful applications on top of it. And by being very low, you could make large decisions, but leave freedom for others to express themselves, in different ways and be very efficient and can be actually embedded in the very fabric of internet itself. Most people may not need to know about it, but then we all of a sudden have a better foundation to build a large, structure, various kind of different application domains. You can move into many things. A lot of the ill of the things we may observe, I think if you drill down, eventually have the roots in the early foundations of the internet where we were more, I think, interested in efficiency and also how to reach everybody, which we succeeded you know, yeah, like crazy. And but unfortunately, some of the important issues are compromised at that point. So we're trying to see if we can fix that. That's a long introduction.
That's probably very helpful. Sam.
So I started life, I got a PhD in electrical computer engineering and then became an academic, eventually became a full tenure professor of ocean engineering, which was a multidisciplinary department. Did a lot of research for the Department of Defense in robotics and machine learning. My dissertation was on a form of reinforcement learning. So I was a very early pioneer in AI back in the late 80s and 90s. Most of the work that I did as an academic was with autonomous underwater vehicles, so robot submarines, and then branched out into survivable shipboard automation and IoT-like things, and eventually retired from the university and then continued to work as a defense contractor in autonomous underwater vehicles and survivable shipboard automation. Eventually decided a lot of the research started to go classified, so I didn't want to get stuck in a classified lane, and so I branched out into cloud automation systems, and that led me to trying to solve security identity problems on the internet, and wrote some white papers that eventually resulted in something people call SSI, and then uh, uh, originated the carry protocol. And I think from my perspective, the trust spanning protocol is derived from a white paper I wrote. It's now what, 3 years? Is it 3 years ago? Yeah. Wow, time flies. That's trying to solve the authenticity problem of communicating over the internet with as strong as authenticity from a security perspective as you can have, and then leveraging that to get as strong a confidentiality which as you can have. And then what's left is the to address surveillance privacy from metadata surveillance privacy. So I think it's a pretty good protocol for solving those problems, and had a lot of help from Drummond and Wenjing to to, you know, turn that into a specification. So, Wenzhing's probably done most of the heavy lifting on the specification part. Anyway, and right now I spend most of my time working on the Carry protocol, Carry community, advising companies that are using Carry and ACDCs and things like that.
Yep. Fantastic. What, Sam, remind me of the name of the paper. I've got a blank in here.
SPAC.
Yeah. That's
So
right.
secure, privacy, authenticity, and confidentiality. Not in that order, but that order makes a word. Trying to do it in the other order probably it doesn't work very well. So
All right. Besides his architectural genius, Sam is, I call him the king of acronyms.
In
What?
my work, I had the best acronym because I was measuring fatty acid retention times, and we decided not to put it in the paper. Parts. So I'd be talking with my supervisor to be like, "What are the farts like today? Oh, they're looking pretty good."
There you go.
Stable. So just
Yeah.
really quick, I have a PhD in microbiology. I work in research data management at the University of Guelph. Drummond, you can copy it, right? I put it in the chat so you can copy it.
Thank
I'm
you.
interested in decentralized technologies. I have nothing to contribute to the trust spanning protocol, but I'm here to learn about it because I want to make the concepts more accessible. Because yeah, I think that's a gap, and there's a lot of cool stuff. But so there's their YouTube link, and that's one of the things that I've been working on.
And I highly recommend Kevin as someone who communicates about technology and these concepts. Carly's came up with the idea for bite-sized trust, and they're all everything's under 3 minutes, right, Carly?
Yeah.
Yeah. So they're just chunked down. Go ahead.
Yeah.
I love the thickness, so thank you. And
Yeah.
I've got a couple more nuggets to drop in so you can better pigeonhole me too. I love cryptography. I'm a bit of a hacker. I like to know how things can go wrong because I've run databases that had credit card information to transactions, and also worked in OT safety systems and refineries, and
Nice.
which are constantly under attack. So
can I, if I'm working on concepts, I like to reach out to get verification of correctness of my scripts. So maybe then, or we can talk about ideas that can be solved. Awesome. Thank you.
cool.
This is great. As you can tell, it's a small group today, but it just happens to be, what I consider the real, a number of the real superstars of the work at Trust Over IP. So glad Kevin's all able to meet you and understand why I've been, he's heard me droning on about Trust Over IP since we spent a week together at a workshop in Greece in the middle of July, right? I think it was roughly that time.
Yeah.
Exactly. All right. Well, interesting, Kevin, you're coming where besides our standard thing we've been doing really for months now is just reviewing any open issues and slowly closing them on what's getting to be a pretty mature spec. As Kevin knows, he's also one of the folks that showed up as volunteering for the new decentralized trust graph working group, and sort of the rule we have to follow, because meetings are always full, is if you open a new group, figure out which other one you can not have to have meetings for. And so given that right now we've been meeting every other week, so we put the kickoff meeting of the Decentralized Trust Graph Working Group in our off week slot last week, and everyone said, yeah, this time frame works really well. And since that group is going to start meeting weekly, the question was, well, do we need to continue? And we had discussed loosely the fact that maybe we don't have to continue to have regular meetings, but we certainly need to continue to be able to say, hey, we do need a meeting, whether it's to dive deep in an issue or, reach an approval point or whatever. So, because I'm one of the co-chairs, we'll find out who else is going to do it at the other meeting. I said, well, what if we take over, what if we go into async mode and take over, and give them that meeting slot? But the agreement is anytime the trust planning protocol task force needs to meet, whether, for part of an hour or the whole hour, as long as they give us a week's notice, we just say, okay, because what the decentralized trust graph working group is doing is so dependent on TSP. It's like, yeah, anytime you need the meeting slot, you just give us notice and you meet. So it's a reserve slot whenever it's needed. But in the meantime, that group will start meeting weekly. That's a proposal on the table. Any thoughts about that?
Yeah, I think I shared already. I think it's a good idea. These meeting slots are very precious. It's hard to really have a time that so many different time zones can join together reasonably well. So on the TSP side, we would probably have discussions to because we'll get into sort of finer points once we start to really making progress on implementation and potentially interoperability. There will be finer points. We'll get into, for example, this debating about efficiency, compromise of one way or the other. That sporadically we'll probably want to do. And we also want to have a good enough portion of the people paying attention so we get more voices at that too. So on both kind, I think this is a good arrangement.
One other, you bring up another good point about why I suggest this, sort of connection between these two groups, because I believe what we've got, we had a total of 37 people show up for the decentralized trust graph working group. Between the two meetings, we have a North America, Europe, and I mean Americas and Europe. We stopped saying North America and Europe because there's my wife's former wife's actually from South America, and an APAC meeting. But the point is, I think that group, including folks like Kevin, who's been exposed to that, is probably some of the most interested in those questions. So we're likely to draw, when they're used to that meeting schedule, and we say, hey, we need a TSP meeting, a bunch of them will probably come to learn and weigh in, and so I think it's a good audience, sort of co-audience to have for us. So that was the other reason to pick this particular approach. All right, well, if there's no objections, and I know that there's already folks saying, we said when we met last week, our first meeting would be next week. We're going to start meeting weekly, but we needed that 2-week window to figure this out. So I will make it so, and we don't have to spend any more time on that administrative issue. And we can move over to our favorite subject of working the issues list. And this is when I turn it over to the real architects, Wenjing and Sam, to say, okay, what is it that you need to talk about now? And do one of you want to share the screen and look at the issues list, or what do you want to do?
Yeah, we have a issue list. I think there's a one item there discussion going on.
Do you want me to show that, or do you want to display it?
Yeah, why don't you show that?
Sure. Okay.
And I have another topic I want to bring up as well. Also yeah, go ahead.
Hang on, I want to copy this in so that if Kevin wants to look at it directly or anyone else.
Yeah.
Oh, interesting. It now actually copies the text as a link. That's Zoom chat's getting more sophisticated. All right.
Okay.
Anyway, we'll pop that. Wait a second. That's right. You got to go to.
Select.
Is it this one?
I guess. Try that.
I want to open a new window in link card. What? All I want to do is go to the link. Open link.
Maybe that. Yeah, open link.
I didn't even realize they had. All right. And which,
So the discussion, TSP, but yeah, I think that's the one. Yeah. So this question is coming down to because we are thinking about like the version encoding for TSP, and beyond the exact format is one question. I think Sam, you proposed a shorter format, which looks good to me. The main issue I have is whether we want to encode the table version and the protocol version separately. And we're trying to figure out like what do I do with the protocol version, and also the table version, the two different versions. We'll see two numbers. Like for as a receiver, what can I do about it? And it's very hard to because it's a encoding scheme, so it's kind of harder to say um, what I exactly I suppose. For suppose there's a version change that a bunch of a new code points got added to it, but TSP may not care about those code points. Um, in that case,
Yeah. Yeah, go ahead. I'm
yeah.
just
So in
saying.
that case, we may not want to sort of IA to sort of reflect that change, and two, the implementation may not care about it. And so in at the end of the day, I think people just need to or the TSP's versioning. When we do the TSP's version, we will set on a set of or a version or a set of the code points that we must support and be done with that. Basically, it will be a deliberate change every single time. And we hope that in the long run, won't be changed that frequently. Anyway,
Yeah,
yeah,
I agree with it. I'm fine with that. The reason I proposed it is because for the other protocols that are using Caesar,
right.
Carry and ACDC, um, there's quite a bit. There's a much tighter binding between those protocols and Caesar, and they use uh, the they like it's at a lower level in the sense of how they message things, and so the so
For
we
ACDC, will be very clear, right? Because they say
yeah.
exactly what it means, and so
Yeah.
it's directly.
So since we decided to include the Caesar table version, I wondered if we shouldn't have all the protocols do that. And what I was trying to voice is the reason for that. Um, there is something that actually, as I thought about it some more, makes it less applicable to trust spanning protocol. And the reason is that a Caesar stream can have the table version in the stream. In fact, that's the way at a top level of a stream. If you're not tunneling another protocol, you start the stream with the table version,
Mhm.
independent of whatever else. So actually, the TSP messages where the payload is a Caesar stream can actually message what version of Caesar the embedded payload uses, which means that as long as
Correct.
the stuff that's happening in the TSP wrapper is uses a limited or a set of the protocol of the Caesar table, they can be
Right.
different. So you
Yes.
can say we're only using version 2 of the Caesar table. We're not using version 2.1, but the payload could use version 2.1.
Exactly. And that the payload can have, a lot of things built into it. And so that the
Yeah.
TSP proper only has very limited use of it. And we will lock that down, so make the implementation a lot easier. And then, the protocol doesn't need to change all the time, right?
Yeah, well, yeah. So what happens is that the reason we decided to use to message the table version
Yeah.
is that we anticipate that the Caesar code table will change a lot. And so what
Yeah.
happens is that we've got multiple protocols dependent on something that is changing faster than those protocols would otherwise change. In other words, I don't anticipate the TSP protocol to change hardly at all. But if every time we need to include new entries in the Caesar code table because of new cryptography, right? Then you're changing the TSP protocol, not because any of the structure or the messages or the field formats or anything change. It's just that you have new code points for new cryptographic primitives that you need to be able to uh, accommodate, and that forces you to version the TSP protocol. And
Yeah.
so
Yeah. Yeah.
if you're okay with that, that means you're going to be versioning the TSP protocol way more often than you would otherwise, because as soon as a bunch of new crypto comes around, like there's going to be a bunch with the post quantum stuff,
Yeah.
every protocol dependent on Caesar is going to be versioning just to pick up those new code points. Whereas with ACDCs and carry, since we versioned that separately, the protocol itself doesn't have to version, because it
Right.
goes, oh, we're using new code points in this message, and it's this version of the protocol, but it supports the latest code points. So
Right.
you can
Right.
inject it facilitates cryptographic agility governance a little bit smoother. But the trade-off is you're sending an extra 3 bytes with each wrapper, which for a tunneling protocol is not ideal. So
Exactly. And also that the fact that a version of the table seem to suggest that we support all of them, which, even if we are, let's say, we are adding these encryption code points, other code points that also get added to the table may not be used in TSP, right? And so we could use the dot version for that purpose, like for the algorithms,
yes, yeah,
and that would be, I think, doable. So yes, every single time we add a new encryption algorithm, we would change the dot version, for example. So
but
that,
not the yeah. And
right.
so that's just how you yeah. So that's a good way to split that and just say major versions now have to do with changing the TSP protocol, and you can do and since you've got 64, since it's a base 64
Yeah,
character, you've got 64 of them, and most protocols rarely get to version 3. So yeah.
yeah. So
Uh,
that's should work out
that's
okay.
probably enough space. You might end up getting to version 16 or something, because you're versioning the major one more often, because you're
Right.
reserving the minor one for the code table changes. So that's a good compromise as well. I like that idea. So,
Yeah, yeah. Great. So we can have a resolution on this particular item. And then I have a,
but
um,
we need to describe in the spec what the policy is for how we're using those 3 version characters, right? There's a major and 2 minors, and just so that we codify what we just discussed,
sure,
right?
yes, I think so. You're right. Yeah. So I don't know to do about the last one, maybe just editorial changes or, that, or um, what's even minor than that would be,
Well, yeah. So the minor version is for any change at all that would re, that would not be uh, that would require a change for somebody for interoperability, right?
yeah.
Uh,
So a new algorithm got added. Of course, that is a change that
yeah.
will impact interoperability and functionality as well. So the last the you know the yeah, the third point of version would be maybe cosmetic changes for, let's say, document have errors, clarifications, and those things don't really change the protocol implementation itself.
Yeah.
Maybe that would be three different versions.
Because you're following semantic versioning, I think. You're
No, we're
consistent with
not.
that.
Semantic versioning has two dots. So it has a patch, which it doesn't change
Ah,
functionality, right? And then the
yeah,
minor is the minor in the semantic would be the minor in our case, and then the major would the major in semantic. But if we're going to, usually the minor is non-backward breaking changes, and the
yeah,
major is reserved for backward breaking changes.
yeah,
Which means, if I'm a 2.1, then I can still parse and interoperate with the 2.0. A
yeah.
2.0 can't interoperate with
The
me,
1.2.
right? But right, but if
Yeah.
we're going, but if we're going to say that code table changes are in the dot, then we might end up having what would normally be a minor change because it's not backward breaking, end up showing up in the major, which is signaling to everybody this is backward breaking. If you're a 1.x whatever, you can't expect that a 2.x even understands what you're saying, but we could relax that and say not every major upgrade is backward. Not every major version change is guaranteed to be backward breaking. It
Right.
could be
Okay. So
back.
your major is more encompassing, backward breaking
Yeah.
and not backward breaking. And your minor, why you can expect everything to be functional in a backward compatible manner. And number three is the patch, semantic versioning, which for you is cosmetic.
Yes. It doesn't, because we're a protocol, we're not code.
Mhm. Okay.
And code, the patch says, well, it's a different version of the code, but functionally it's the same. What we did is we cleaned up the comments, or we fixed a bug, right? Which is, we didn't change the protocol, we just actually weren't implementing the protocol correctly, right?
Yeah, clarifications. There's a ambiguity, for example. We need to
Yeah.
all things like that. Yeah.
Yeah. So normally we don't need the patch. That's just wasted bytes. Um, so we have plenty of code space in the minor, because for each major we've got 64 times 60 4 minor versions. So we have quite a few minor versions, since it's base 64. Um,
All right.
so yeah, so that's a way to address that.
Very good. Very good.
All right. I'm not sure if in this, I'm happy to leave this comment, but I'm not sure I'm capturing everything that you've,
That's okay. I'm going to comment and this.
Yeah, so this. So we're going to do the same 7. So the original 7 character protocol string that has the protocol and then a version, and then the encoding character in the front of it, which was was it X or Y? Yeah, it was Y, I think it was. Yeah.
Yeah.
In
So it
the
will
Caesar.
be start with a YTSP. That's continue to use that.
Yeah, YTSP underscore, because TSP is not 4 characters.
Yeah.
Um,
And then followed by the 3.
the 3, yeah.
Okay, good. Okay. So essentially, the format-wise, no change from what we already have. And we will explain these 3 versionings and also how to deal with code table changes.
Yep.
Good. Let me bring up a, which hasn't been written down yet, but it was more of a discussion or question. The count code and how it's best implemented in the sender side.
The what code?
The count code. So like,
Oh, the count codes.
yeah.
is this an existing issue or a new one?
It's a new one. It's not necessarily an issue, so we are just talking about it. Yeah.
Okay.
The count code, like let's say if I send a message in the with a payload, and I'm getting the payload from somewhere, but I wouldn't know the length until the encoding is done. So it seems like the processing would be you leave the code there, and then starting to do the conversion or encoding portion. When it's done, measure the length and then fill it in. Seems like a very inefficient way of have to come back to it. Is that how like in your implementation, is that how you do it, or how that works?
Yeah, so if you look at framing, self-framed, codes
Yeah.
where the framing code is a prefix, that's the only way you can do it, because you can't calculate the count of the number of bytes that are in the frame until you know the size of the frame.
Yeah.
But it means that the parser is super efficient, because the parser doesn't have to look into the frame to know how many bytes are in the stream. It just parses the prefix and goes, hey, this is where I'm at. Now you can optimize that, because if you're going to do a count, whether you do the count after the frame or prefix frame, that's just, you're just storing to the side as you're parsing the frame, how long it is, and then you just
Okay.
prefix it. So it's just a matter of, are you using uh uh, if you're, depending on what language you use, in Python we use byte arrays. And so the byte arrays have an extend thing where you can add to the byte array really efficiently, but you can't insert very efficiently.
Mm.
So what we do is I just create a new byte array that is, and concatenate the other byte array, and that's really efficient. Once you've encoded that,
Yeah.
encoded
Yeah.
the frame, right?
Yeah. So
Um,
I'm working with Rust, and then um, it seems to me it will be it's moving some of the burden from the receiver to the sender. So the
Yeah.
sender,
Oh yeah, absolutely. But
yeah,
the receiver is the one that is usually in a high in a at scale situation is where you have the bottleneck. So we've talked about, so one of the things this was designed to do was to have the property of and Caesar has the property of what some people in the academic community call core affinity. And what that means is that in data centers, the pipes between the servers can send more data than any core on any server can process in real time. And that means that in order to process that stream, the server has to be able to split that stream and have it processed by multiple cores simultaneously.
mm,
And that means that the splitter, the parser, has to be
yeah,
able to pull off big chunks of the stream and shunt it off to a core and immediately get the next one, because it's coming in too fast. You've got 400 gigabit per second fiber. I think they're now getting, getting, I know that some have at least 400. They might be 600 or 700 now, right? But even a 40 or gigabit per second fiber is faster than a 5 gigahertz core can handle. So you even the lower end ones are, even 10 gigabit per second is hard for most cores to handle. So my house has 10 gigabit Ethernet in it. So
yeah. The so that benefit is valuable if the decoding does not have to be done right there on the spot. So you can
that's
just
right. That's
um,
that's right.
yeah. But if you are decoding at the same time, then it's the length doesn't really help you that much. You have to linearly go through it anyway.
That's right.
Yeah.
But
So,
that's why HTTP 3 has gone UDP, and they added pipelining so they could support core affinity. So
yeah.
so I wanted to future proof Caesar. I didn't want to build an encoding scheme that is stupid like JSON or CBOR that can't be made core affinity without adding yet
It would
another
be
protocol on top of it,
it would
right?
be nice to have I don't know who will be the right person to try to do a very low level implementation with multiprocessors. So that would be
Yes,
actually a good way
right.
to
And
prove.
in real-time video streaming protocols
Yeah,
uh, also do framing codes so that you can drop frames
I
as needed when you don't have enough processing power to process the frames. And dropping frames is much better than dropping the stream. And
yes,
so if
driving frame is good.
yes,
With
so we
the
can drop
time code,
frames.
it's easy to drop. It's
Yeah, so it's
really
easy to
easy
drop
to
frames.
jump forward and throw something to somebody or throw it to trash. That's
Yeah, and you don't have and you don't and you could just throw it to a buffer, right? You could
yeah,
just throw it someplace and say, "I'll come back to it later," but I don't want to drop the whole stream and force a reconnection, right? And that's one of the things that is why HTTP 3 went to UDP instead of TCP, because when TCP fails, it fails catastrophically, and all of the in-stream packets get lost, right?
so the
Whereas
payload, let's say we have a very long payload. Um, to verify the signature, you will still have to go through the payload, right?
that's right. But the signature verification is a cryptographic operation. So you're gonna have to send it someplace to verify it, that signature. But you don't have to process inside the payload. You can
You're right.
jump to the end and grab the signature
So you can
because
process the beginning of the TSP envelope and
yes.
then simply jump both the payload and the signature off.
Yeah, yes, that's right. So in a Caesar stream,
Mm,
you have messages and you have attachments. So you can use a group code that is a framing code that frames the combination of message and attachments, or you can use a group code that frames the message and the attachment separately, which means you can pull off the whole message as a byte stream without processing it, grab the signature, throw both of those at your signature processor. And you didn't have to look into the message itself. You pulled off the signature, verify the signature, and then you can drop the whole thing if the signature doesn't verify. So it gives you the options to optimize your in-stream processing of signing as well.
yeah, it will be good to because most of the today's processors have a special engine for decryption. Um, I'm not sure about signature, but the
No,
decryption
they don't do signatures very
symmetric,
well.
yeah, symmetric decryption, they probably do it, right? So you could,
Yeah.
yeah, it would be nice to sort of have some implementation to actually
So the
be
encryption,
implemented.
yes, because the payloads will be encrypted. So first you have to decrypt the payload, right?
Yeah,
If you want to see inside the payload, but because the ESSR, you're signing the encrypted payload, you don't have to decrypt. So you verify the signature before you send it to the decryption engine
I see. Yeah,
on the TSP payload. So basically,
right.
you don't want to dig into that. You just want to be able to skip to the end, pull the signature off, verify the signature on the whole wrapper, and then send it to decryption. And then you'll have embedded signatures after you decrypt, but it should be the same sort of stuff.
Yeah,
So
yeah,
yeah,
yeah.
so Caesar has all of that complexity already designed in, and it's a little bit, more work,
Well,
but
I
we
will.
won't be having to do uh you, you know but it's protocol agnostic now because it'll work on any bare metal protocol. And it supports all of those advanced features because it's already designed that way. So
Yeah, I would say like as early as possible, if we could have a low-level implementation, which would take advantage of a hardware assist on decryption that way, I think that would we will be much more confident to say like, hey, this scheme actually would work really well.
oh yeah, I mean that's
Yeah.
yeah,
So anyway,
yeah, I mean I've done enough protocols at low level that that the bit flipping and shifting and all of that stuff, right? There's nothing in there that I I'm worried about because
the bit shifting is, yeah. So yeah. Okay. So I think in theory we know the benefit clearly, and that's the main benefit of for the receiver to be more efficiently handle it, or they give it
yeah,
more freedom to handle in different ways.
yeah, which is where the bottlenecks are at scale, not on
And
the sender side.
the sender would just need to just change the logic a little bit.
Yeah,
Um,
but it's no worse than senders that are sending real time, like real time streaming protocol, right?
yeah,
Real
yeah,
time streaming
of course.
protocol. If
Yeah.
if you've ever implemented real time streaming protocol, you wouldn't be surprised at Caesar. You would go, oh,
No, no, they will be much more complicated actually.
yes.
Yes, yes.
And one of my development projects years ago was in the early days of MPEG when it was still not supported in chips very well, as I had to write. This is for an autonomous surface vehicle for military purposes, where we wanted to have live video remote control, so like now what people do with drones, right, where they
Yeah.
just they have the thing,
Right.
right? But this is back in the 90s. Oh, no, or okay, I guess this was early 2000s, but when MPEG was just getting started.
Right.
And so I had to do a lot of low level stuff to try to get 30 frames per second with MPEG over a wireless, yeah, wireless connection to a surface shift that was designed to uh, be a really fast autonomous interceptor, right? So
Yeah.
it could, right, like 60 mile per hour drone, surface drone that could carry weapons and blow up, things.
Yeah,
Yeah.
it will be good to have a well, one is a 86 core implementation. And the
Yes.
second would be maybe we'll do a ASIC design to do it in real hardware. And that would
Yep.
be
Yep.
yeah, those two would I would
Yeah.
then we can say the protocol is a version 1.
There you go.
That we didn't miss anything, that actually it is
Yeah.
as we imagined it. Yeah.
Yeah. Well, yes.
Hey guys, Kevin asks in chat, the project that he's involved with uses CRDT and so small compact packets would be really helpful. How well suited is TSP for that?
Well, when you convert from base 64 to base 2, you are quite compact. Um, there it is. You're not compact at the absolute minimum that you can be with if everything is just bit fields, because you have to be aligned on 24-bit boundaries. But most of the overhead is going to be cryptographic primitives, and so you're as compact as you can be with those cryptographic primitives and still have cryptographic agility.
Great. Thank you. Thank you.
Yeah.
So if you want cryptographic agility right now, and you're going to use something like Jose, which is the CBOR version of Jose, then you're looking at field maps for a single cryptographic primitive. So a public key isn't 44 base 64 characters or 33 bytes. which would be only 1 byte of overhead in Caesar, right? You have 3 times the length of the actual public key in overhead in CBOR, because you've got labels and then fields. So you have like, well, this is a signature, and what type is it? Well, it's a string that says it's ECDSA or ED25519, and if it's ECDSA, what is the curve that you're using? So you've got multiple fields, and then you have the field that has the actual public key in it. And so you have all of that overhead. So when you look at carry messages, and I just did an example at IAW one year, and you say, well, if I were trying to encode what's in this carry message, what has like 15 or 16 cryptographic primitives, using COSE and the SD jot, it blows up to like 15 times the size of a carry message, and the only advantage from that blow up was cryptographic agility. So Caesar is already future proofed for cryptographic agility, about as efficient as you can make it. Nobody does it more efficiently. I'll stand by that.
There you go.
Okay.
I
I
put
like
link
that. Thank
back in the chat there, Kevin, so you can check that out.
Yeah.
Which is maintained by the Carry Suite working group at Trustor IP. So which Sam chairs or co-chairs, whichever one. Cool. We have 3 minutes left. Is there anything else, Sam or Wenjing, you wanted to bring up on issues discussion today?
I'm taking 2 weeks off, starting end of this week. So next 2 weeks I won't be here.
Gotcha. Okay. We'll miss you in the decentralized trust graph meetings over the 2 weeks. We'll probably veer way off, and you'll have to bring us back onto the track. I'm kidding. Okay.
Otherwise, the implementation is going well. We are in the process of releasing a .9 software. So so we have a .8, and now we have a .9 version of the software. Hopefully, have most of the revision 2's encoding implemented. There are a couple of issues. So one of the issue, well, getting the software issues now, so probably skip it. But so I'm hoping that in the next week or two, potentially before I leave, we'll have a .9 release. Yeah, in that repo there.
Cool. Excellent. I'm just giving that pointer to Kevin if he's wanting to check it out. Sounds
Right,
like
and there are demos software. There's a lot of MCP based demos for AI agents, and there's quite a bit of you can play with.
yep. And Sam, I don't know if you have I gave Kevin the Caesar spec, but if there's any URL that you think he should you want to put in the chat for checking out the carry implementation, please do, just because I know he does.
Oh, yeah. So there's a carry implementation and a Rust implementation of Caesar. The Rust implementation is stale. Nobody's really contributed to it for a while, so it doesn't include the Caesar version 2 updates. But there also is a Rust one. But if you go to Web of Trust, here, let me get the link.
Yeah, put that in the chat.
And you can see those repos. Gosh. There we go. So the carry pi repo is there, and the Caesaride, that's the one that has the Rust version of Caesar.
Yeah, the TSP implementation is also on Rust, but we did not use this Rust Caesar code because it's not active right now.
Yeah.
Why is it inactive?
There was a small startup that wanted to implement Carry Suite for a proprietary product. And so they had a developer who worked on it, and they were doing it in Rust. And he contributed back to the community the Caesar Rust stuff that he did. Because it was a small startup and they wanted to do it proprietary. He didn't contribute back the carry or the AC/DC code he did. And once they went to production, they just stopped. So I think he was basically saying, "Hey guys, I'll contribute this if you help me understand carry and Caesar and stuff, even though I'm doing a proprietary product." Because he's the developer, he would have contributed all of it back, but his bosses didn't want him to. So once he got it into production, they just told him, no, don't contribute any more stuff back. So this is a common problem in open source. So I've helped multiple companies build carry AC/DC Caesar implementations as part of the open source, and they don't contribute back, or if they do, they don't continue to support what they contribute. So, and I don't have the resources to maintain all of those unsupported contributions. I spend all my time supporting the reference implementation, which is the Python version. So all the good stuff goes into Python, and if people want to port it to another language, they're welcome to. But so far, nobody has invested the resources to support another language and keep it up to date.
Makes sense. Thank you.
This is the third company that has done a Rust implementation. There's another Rust implementation that the Human Colossus Foundation supports, but they changed from the Apache 2 license and forked to use the EUPL license, which is the European specific copy left or reciprocal license. And so they continue to support that. They're probably a year or so behind the Python, in terms of feature set, but that's the most updated one. But you have to deal with their not so free license. So anyway.
I have to jump off to another meeting, but thanks for letting me eavesdrop and slow things down just a bit. I appreciate it.
Well, that's fine.
It's always good. Share the knowledge. Appreciate it, Kevin. We are over time, and I got to jump to another meeting too. So thanks everyone. And again, we will now be going to the asynchronous mode. But anytime that we decide to need to meet, we'll just all we have to do is put your hand up, and I will schedule it. I mean, we'll just take that slot. So thanks everyone, and enjoy the rest of your day. And Kevin, you
nice
got
meeting you,
good
Kevin.
shot. Exactly.
Yeah. I
we'll
really appreciate y'all's work. Thank you so much. Yeah.
Yes.
And Nick Carly.
Over the coal face.
Thank
All
you.
right. Thanks a lot, and goodbye, everyone.
Bye-bye.
Bye-bye.